In this lecture, I will explain you what is energy. So if I speak about energy, I say it is the capacity of a body to do any work, right? Basically, if we don't have energy, then we cannot perform any work. Okay, so energy is the capacity of a body to do any work. If there is a energy, then there is a work done. If there is no energy, there is no work done. Okay, so energy exists in many forms. Like you have heard about light energy, heat energy, chemical energy, electrical energy, mechanical energy, right? So energy exists in many forms, but in this chapter we will just discuss about the mechanical energy. So when we talk about the mechanical energy, there are two forms of mechanical energy which you have heard already. The first one is kinetic energy and the another one is potential energy. So I can say it is kinetic energy and potential energy. So if I speak about kinetic energy, that means I think automatically kinetic energy means if an object is in motion, then the energy possessed by this body is known as kinetic energy. Okay, so kinetic energy means the body is in motion. Okay, potential energy means if the object is at rest position. Okay, so you must remember, if I'm speaking, if the object is at rest position, that means we are speaking about potential energy. If the object is in motion, we are speaking about the kinetic energy. Okay, now we will calculate the formula of kinetic energy. Okay, how do we calculate the formula? So again, before calculating any formula, there is a figure. Suppose it is a ground, there is a ball here, there is a ball or any object, you can say. Okay, it is at rest position. Okay, and we are applying some force in this direction. We are applying some force, that means it is creating a displacement. When we apply some force, then it is creating a displacement, then this body moves. Okay, and it comes at this position, right? So that means if the body was at rest and then it creates a displacement, then I can say that displacement is S, the force is F, and the body was at rest and now it is moving, right? So let us say when the body was at rest, that means initial velocity u equals to 0 and the final velocity equals to v. Initial velocity, I can say vi equals to u equals to 0 and final velocity is vf equals to v, right? Now in this case, when the body is at rest, that means initial velocity of the body is 0 meter per second and the final velocity equals to v, and it is creating a displacement, right? So basically if we apply a force, there is a displacement, so that means we say there is a work done, right? So I can write work done on the body will be work done equals to force into displacement, because in this case I have denoted displacement with S, then work done equals to force into S, right? So this is my equation number 1. We can denote it with D, anything. The thing is force into displacement. Now we need to calculate the formula. That means I need to reduce the value of force and I need to reduce the value of displacement. So Newton's second law of motion. According to Newton's second law of motion, right? What is force? Force equals to mass into acceleration. You all know this, right? Let us say this is equation number 2. And there is a third equation of motion. You all know v square equals to u square plus 2as. V is the final velocity, u is the initial velocity, and acceleration into displacement. So if I need to calculate the value of s, then can I write v square minus u square? And I can write s equals to v square minus u square upon 2a, right? Now in this case, we know u equals to 0. That means can I write s equals to v square minus 0 over 2a, or can I write s equals to v square over 2a, right? So that means I got the displacement as well. Let us say it is equation number 3. Now we have f, we have s. We need to put v and s, the value of v and s in the formula in equation number 1, right? So I am writing, substituting values of f and s from second and third in equation number 1. So what is the equation number 1? F equals to f into s. That means ma into s is v square over 2a. And I can say a and a is cancel out. That means work done equals to half mv square, right? And if there is a work done, then there is a energy. So I can say kinetic energy equals to half mv square. So this is the formula we have deduced for the kinetic energy. You need to remember this formula, right? So from this formula, we can say that kinetic energy is directly proportional to the mass of the body. I can say mass of a body, and kinetic energy is directly proportional to the square of the velocity, right? Now, if I need to reduce the formula of kinetic energy in terms of momentum, right? If we need to reduce the formula of kinetic energy in terms of momentum, or I can say that relationship between kinetic energy and momentum. How do we find out? We know the formula of kinetic energy, half mv square. Let us suppose multiply and divide this equation by m. Okay, multiply and divide the equation by m. So if we multiply and divide with this equation, can I write half m square v square over m, right? Or can I write half mv square over m, right? And we all know that momentum equals to mass into velocity. So can I write half p square over m? Can I write it like this, right? So this is basically kinetic energy equals to half p square by m. Okay, or can I write P square equals to 2m kinetic energy, or P equals to under root of 2m kinetic energy. So if I need to find the relationship between the momentum and the kinetic energy, then this is the relationship, right? Now in this case, you can see from this formula, kinetic energy is inversely proportional to mass, right? And from this formula, kinetic energy is directly proportional to mass. Okay, so you need to remember, if there is in any question, if there is anything related to the momentum, then kinetic energy is inversely proportional. Sorry, it's not mass, it is inversely proportional. So it is 1 by m, right? So if there is anything related to the momentum, then kinetic energy is inversely proportional to mass, and if there is anything related to the velocity, then it is directly proportional to mass of the body, right? Now the next topic is potential energy. So I'm writing here, we will calculate the formula of potential energy, right? You all know the formula of potential energy. It's very simple to calculate. So there is no derivation. Suppose there is a ball at a height h. There is a height h here. There is a force which is gravitational force. This is mg. So the ball is basically doing a displacement at a height h. So I can write it, work done on the body is given by. So work done equals to force into displacement. That means force is mg and the displacement is height. So work done is equal to potential energy equals to mgh. So this is the formula of potential energy, where I can say potential energy is directly proportional to mass and potential energy is directly proportional to displacement as well. So this is the formula of work done, or I can say the potential energy. Okay, so you need to remember the formula of potential energy, you need to remember the formula of kinetic energy in terms of momentum, and you need to remember the formula of kinetic energy in terms of velocity. Thank you so much.